Alright, so right now I'm looking at this network delay problem that basically talks about finding the maximum amount of time it takes for a signal to travel from some node to all nodes, if in case you can actually go to all nodes. So the problem statement is, you're given a network of n nodes labeled from 1 to n. You're also given times, a list of travel times as directed edges times I is equal to ui, vi, wi, where u is basically the starting node or your source node, v of I is basically the destination node, the place you're going, and then wi is like your weight, your unit, your time, your distance, whatever. It's basically the weight you're going to use. And then where this is u of I is the source node, v of I is the target node, and then, like I said, wi is the time it takes for a signal to travel from the source to that target. And then we'll basically send a signal from a given node k, return the time it takes for all the nodes to receive the signal. If it is impossible for all n nodes to receive the signal, return -1. So when it says return the time for all nodes to receive it, it's basically saying, like, what is the maximum amount of time it's going to take? Like, not the number of hops necessarily, but just the time. So for example, going from, like, I mean, hops is honestly it's just the number of nodes that aren't itself, so that's kind of more trivial. But for this, it's basically asking you, like, what is the max travel time? So for this case, we have a node starting at node 2, you go to 1, and then for the other pieces that you go to 3, and then you go to 4. So the max time for this would be 2, because the one that takes the most amount of time is the 2. And the idea is that, like, it's not additive. It's not like, oh, I go to 2, then I go to 1, and then from 1 I bounce back, go to 3. Like, it's basically a signal is emitted all at the same time. 2 goes to 1 and 2 goes to 3 at the same exact time, and then that electricity, that signal, whatever you want to call it, is also going to 4. And then you're basically just looking for the maximum amount of travel time, essentially, right? And for this problem, I usually choose to use Dijkstra. Dijkstra is pretty straightforward. I feel like it's the easiest distance finding. Bellman-Ford is another option, but I've only ever used that like one time, and I honestly prefer Dijkstra in my personal opinion, so that's what I'm going to use. And what I usually do with Dijkstra when it's given to me in this form of these arrays, like I have, item that goes from 2 to 1 with weight 1, 2 to 3 with weight 1, 3 to 4 with weight 1. What I like to do to guarantee the format of the data, and it's also pretty much like, it's kind of necessary anyway, because when you're doing this, like, say if you don't, what I want to do is create a map and use it as a graph. But imagine if you don't have a map and don't have a graph, you're basically going to have to use a for loop and go through all the different items related to that node anyway, because you want to try to examine the single, like, node for that item. And basically, in order to format the data in the way that I want to use it, and I think that it's more economical, or at least similar at runtime, I just create a map of type integer being the key, and then list integer integer being the the value, right? And basically this is literally, no exaggeration, just going to be a copy of what you see in the output, where we have the key be 2, and then the list that it's going to have is the first entry is going to be 1, second entry is going to be 1. You could use an object too if you wanted to. I honestly don't know how people feel about that in interviews. I honestly wonder, like, if someone were to say, hey, you know what, actually I'm going to make Puglet class, or in this case it would be an inner class, so we call it like, or not even, you could just do it like this, class package, right? Just call it package, and then what you have is int target is, let's just say target is equal to 0, int or time is equal to 0, right? And then what we could do is package, public package int target, int time, and we could do target equals this, or actually this dot target equals target, this dot time is equal to time, and then you have this like little object, and what we do then is just do map integer package Oh yeah, class's name should be capital. Package. And then graph equals new hash map, right? And then what we could do, and we could actually test this really quickly, because I usually don't use custom objects. I usually just use either map or a list. But sometimes this makes it easier, and if the problem is super complex, it might make sense. So let's just say, really quickly, we want to do a dumb test. Package item equals new package 0, 1, and then let's do graph.put 100 item, and we'll see what happens. Will this work, or is there like, oh, okay, looks like it compiles. Okay, cool. So we'll do this. I usually don't do this. I don't know if this is a good habit to get into. Sometimes the problem, it makes it a little bit easier to have like a little object. But if I didn't, I would have just used a double list. But I guess this is useful as well. We'll use this little package class. You could do this, or you could do this, or sub it out for list integer. Okay. Ooh, wait a second. Let me think for a second. Okay, no, this is fine. This is perfectly fine. What I was about to say was, do I have to implement the comparator for this class? Because I'm thinking of using a heap. But the way I'm going to define the heap, I don't use to do a custom comparator. That you might get in trouble with, because I don't always remember the best syntax. I don't always remember the correct definitions and stuff. So the less you know, the worse you'll do. So maybe avoid it. Anyway, I'll use a package for this time. Create graph, which will take in the times matrix and then just return the or just create the graph. So let's do public void create graph, takes in an int by int matrix, and then what we're going to do here is for int I equals 0, I is less than matrix dot length j or I plus rather, and we're going to do int source is equal to matrix I of 0, where we're starting at. Int target is equal to matrix I of 1, which is where we're going, and then int time is equal to matrix I of 2, which is the amount of time it takes. And now what we're going to do is we're going to go ahead and actually this is a list of packages now that I think about it. List package, because there's multiple packages. Anyway, so let's make a new list package and packages equals graph dot get source, or if that's not the case, so first of all let's do this, source or new linked list of type package, and that's what we'll return, right? And then what we're going to do here is we're going to create a new package temp is equal to new package, where we're going to give it target and we're going to give it time. And then what we're going to do here is we're going to do packages dot add temp and graph dot put source packages. Right? That's pretty much all she wrote. We're basically just creating this we're basically just creating this item, and obviously you can't do this in an interview, but we have the privilege of being at terminal, so let's run this and see what happens. What happens? Graph.get source, new link list package. What happened? Error method. Oh, getter default. Get or defaults. Whoopsie daisy. Let's see if this works or not. And it looks like it works. If you want to do this. If you obviously you probably don't even care about this, but if you want to override the toString method, that way when you call it, it looks a little bit better. Return t equals let's do string dot format t equals that. Let's do unit. Let's just do target and unit. Time equals %pass. And then what we're going to do here is we're going to go ahead and do comma. We're going to do target, time, and that's about it. Now when we do like that print, it'll look a little bit better. You don't have to implement toString. I don't even know if your interview would even care. Obviously, if you're like in a doc environment, you're not going to even be able to do this. But hey, we did it. It looks a little bit better. And now we can, if you wanted to, print it out. But I literally just did that to make sure it runs as expected. So now we have a graph, and now the idea is to basically implement Dijkstra's algorithm. Now Dijkstra's algorithm, the gist of it is that you are basically trying to find the shortest path from point A to point B, and the shortest path is usually determined by the distance to that node. So for example, we want to find the shortest path from point 2 to 3. In this case, it's 1. For point 4, we actually don't know. We need to go to 3 and then 4, and then we'll basically know. So Dijkstra is pretty simple, but it's a little bit hard to understand. At least it was for me the first time I looked at it. So if it at all comes off as ambiguous, if it looks a little bit odd, there's actually a pretty good example on Google I can usually find. Let's see, it's like a little information piece. This one, I like this one. I like this one a lot. And like it uses these infinity symbols to basically say like we don't even know how to get there. Like I have no idea how to get there. It does a pretty good job in explaining these different pieces. I mean, for the cases that we're using it map. So like infinity in our case could be null, infinity in our case could be, you know, a negative number if we felt like it, because time can't be negative. But it's basically explaining to you like how the algorithm works and how it finds the different pieces. And in our case, because we are actually creating the queue, we don't need to assign infinite. So you'll notice when we're going through this example here, where is it? I'm not going to assign a time for node 4 as infinite, and the reason why I'm not going to do that is because we don't know what the time is, and we will not explore it until we get to the point that we discover it, and then we add it to the queue, and at that point we should know the time because we discovered it. But if you're doing a different Dijkstra implementation and you have like all nodes in the queue, you want to put infinite. That way like you either A, you know, look at that node last, or B, it's basically like what do you call it? It's just basically implementation choice. You know what I mean? Like you just can do it. And for this problem, all it cares about is the time. So let's just say that at one point one node is not reachable. That node would then stay as infinity. But for my implementation, it wouldn't be infinity. Honestly, if I wanted to be lazy, I could just basically say like go through all the different nodes from 0 to 4, add, you know, basically look at all the different nodes and say, hey, does this exist? If it doesn't, just put it as infinity. But the problem doesn't call for that. It doesn't matter. I'm just mentioning this because this is how I'm choosing to implement it and choosing to think about it. But you know, keep in mind, maybe you need to actually define it as infinity. Maybe you don't. In this case, I choose not to, and I'm not going to. So with that being said, what I'm now going to do is create the heap. In Java, it's called a priority queue. And all I really care about sorting is the different node destinations and the different times. So all I care about is the packages essentially. So we could use package. And again, pay attention to what I'm doing here, because if you had done this, it wouldn't compile. This would fail to compile. And the reason why it would fail to compile is because it's basically saying like, oh wait, what am I doing wrong? I misspelled it. But it should fail to compile. It's basically going to be like, oh wow, it didn't fail. Wow, I'm so surprised it didn't fail. Well, I wonder how it would do that. I feel like it should not be able to compile. New package 1.1. You definitely, there's no way you should run, dude. Yeah, here we go. Awesome. So when you create a priority queue in Java, there's already a default comparable, and because I didn't implement comparator in this class, it has no idea how to sort this, right? Now, in all reality, I should really implement that in this class, because if your interviewer sees what I'm about to do, which is this, so technically what you could do, right, to avoid this issue, is create a custom comparator, right? You could do this. A comma B. Okay, let's do that. And then go like that. Return A dot time minus B dot time. I don't know if I have to cast this. I probably do. Let's see, do I have to cast? Yeah, I gotta cast. So, let's see. Package item A is equal to package A. Package item B is equal to package B. Right? Let's go with item A dot time minus item B dot time. Now this should compile and work, right? So let's add again. Let's do q dot add new. Okay, so let's do this new package 1.1. Let's run that, and it compiles. Now, if your interviewer is paying attention and you use the class like this, they're going to take off points possibly because you're choosing to use a lambda function to implement this, which is really unnecessary because you already defined the class. All you need to do is implement comparable. So in the sense of trying to do the best job you can, I would say if you're in an interview and if you're in a setting where you're kind of in a rush, go ahead and do this, but call that out. Say the reason why I'm doing this is because I don't remember the syntax, I don't know the exact class definition, you know what I mean? Like, I'm choosing to make this a cast issue where you can run into runtime errors because of the fact we're in an interview and I just don't know, or maybe not even don't know, but say I'm choosing to do this, but best case I would do this and add unit tests, etc., etc. But because of the fact that we are in the setting where I can look up the Java API and we can do this, we can just go ahead and do this. We can do implements comparable. Now once I do this, it's going to complain that I'm not doing something. Abstract does not override the abstract message. Compare to. So we need to do that compare to method. So public int compare to. In this case, we're going to do package input return this dot time minus input dot time. This is how I'm choosing to do that. And now we run it, and why is it complaining? It does not override abstract method compared to. Oh, okay, it's because of that. Oh boy, oh boy, oh boy. Okay. So let's try this. Package item equals cast package input, and then what we're gonna do is item.time, and we'll run that, and it'll work fine. This is fine. This is a little bit cleaner because you're basically doing the cast in here, and if you really wanted to, again, you're in an interview. Maybe you don't have a lot of time, but if you add this, ooh, try catch. Oh, whoa, not of type package. Got you, buddy. I got you. Hold on. I got you, buddy. I got you. I'm not stupid. Let's do that, and then let's actually do throw new illegal argument exception, and then let's see if this runs. Bingo. So now we pretty much did a lot of extra stuff you don't really need to do. And by the way, what I just said, that using a runtime based lambda definition, this right here, A, comma, B, arrow, and then whatever logic you want. Very useful. When you do other problems that are more difficult or have more logic within the heap, and you don't want to create a different, like class, like you don't need a class, you just need a heap. Very useful to do this. It's basically going to save you a lot of time. Also, if you're creating multiple heaps, it'll save you from creating multiple objects, but for this case, I think this is fine. So now what we want to do is we want to do q.add new package, and what we want to do is add our source, which is k, and then add the distance or time to k, which in this case would be 0 because k goes itself in 0 time, right? So now what we want to do is we're going to do int max equals, let's say -1. Let's just return max in this case, right? And then one thing I want to do also is I want to keep track of all the different distances and how to get them. And for that, I'm going to use a map. I'm going to do map integer distance, or in this case, technically time map equals new hash map. So for context, this time map, if I gave it 2, it would spit out 0. If I gave it 1, it would spit out 1. It's basically telling you in context. Here, we could even add it as a comment. In context of source node, what time distance from target keys, target value is time. So you could do that. You could add a little bit of a comment if you want to. Again, I'm trying to be as explicit as possible. In an interview, maybe you won't have enough time. Sometimes interviewers give you this problem and then they really don't care. They literally just want you to solve the problem and immediately go to the next one. So maybe ask them before going through it. Say, hey, is this the only problem we have in this 45 minutes, or is there going to be 2? How should I pace myself, etc., etc. Try to set expectations, because in an interview, you're probably not going to add a toString method. You're probably not going to add a Compareto method. I'm literally doing this just to be as explicit as possible, as opposed to rushing, because I'm at home, I have the leisure to do this. But in an interview, I probably would have made the object. I probably would use the runtime lambda for the Compareto logic, and maybe I wouldn't add comments. I don't know. It doesn't take that much time, but maybe I wouldn't. So now at this point, what I'm going to do is I'm going to say, wow, my queue is not empty, right? It's not empty. Let's go here and put the exclamation point. What I'm going to do is this. I'm going to get a package, right? Package item equals queue.pull. And from this package, int source equals item. By the way, did I make these items public? Public. Let's do that. Public. Oops. Public int target. Public int time. I'm not doing an accessor and mutator. You can mention that's best practice, but you don't have to do it. Int source is equal to item.target. Int time is equal to item.time. And now what we want to do is we want to start fulfilling the distance map, distance.put source time. Let's fix this typo right here. And this will basically tell us that we have the distance of time. And we'll also do max is equal to math.max, max or time. We're interested in the time. And now what we're going to do is basically start interacting with that graph which we had created earlier. We're going to say if graph.get source does not equal null, like if there's something to get out of this, for list, or no, yeah, it is a list of packages, it's called package list in this case, graph.get source. So we're basically just going to go get a list of those items. We're going to go ahead and say int source is equal to, let's think, it is what? Let's think. I think I'm wrong. I This is package. Package item, right? They're basically going through all the different packages. So int source is equal to item.target, or not source. Let's call this target, I guess. Target, and then int time. Or well, actually, we can't do that, can we? Because we already source time. We could just call a unit is equal to item dot time plus the time we defined up here, because what we're doing there is basically we're starting off from root, and then whatever this time that we know of, we need to add whatever previously it took. So if we're starting from 2, what previously took was 0, but then if we go to 3, what previously took was technically 0, because we're going from 2 to 3. The last time was 0. 3 to 4, the last time it took 1. So 1 plus 1 is 2. That's how you get the 2. And one thing we're always going to look for is if distance dot get target. What did I name it? I called it time map, right? Yeah, time map. I usually call it distance, but in this case I'm using time map. So if for some reason time map dot get target is non-null, that's an issue. We already saw it. Continue. Already visited node and calculated time. Do not do duplicate work. And now, if the case is, hey, we are looking at a new node, it's not a duplicate, what do? Well, it's pretty simple. We just add it to the queue, honestly. Queue.add new package target unit, and that's literally it. That's pretty much the problem in a nutshell. And then one thing we want to look out for is, because we are doing this in the case of discovery and not all items are there. So for example, if you wanted to, this original time map, we could have all nodes there, and we could have infinity for one of them if we never find them, and then if any contains like infinity, we could loop through and find it and say, hey, one of these times is infinity, return -1, we can't get to it. But because I'm doing the discovery method, if for some reason we can't get to a node, the idea would then be that, hey, of all the 5 nodes, I only saw 4. Okay, if distance dot get, or dot size, rather, oh, first of all, it's time map. If time map dot size does not equal to n node size, return -1. Pretty much it. Let's see if there's any errors. Yes, there is. What's the problem? Item is already defined. How funny is that? Alright, let's call it PKG. Nice 3 letters right here. PKG. PKG. And that's about it. Let's see if this runs now. And it's wrong. Why is it wrong? The reason why it is wrong is because of the fact that... Oh, hold on. Are we double checking distance up here? Are we time checking that? No, we're not. So, whoops. So basically, for this max right here, we want to not do any duplicate pieces with it, because it's possible. So you see how, like, right here, we're doing this dupe check, right? Like, we're letting dupes come in here. Technically, possibly. And let's see. Yeah, we're technically letting dupes in. Or not so much dupes, but it's possible that we get to a point where, like, we've already seen the time for node 3, and 3 comes back and it's irrelevant. So the first time we see a node is the only time it matters. So let's see, distance dot get source equals null. And of course I'm again not using the right name of this bloody map. Time map dot get source equals null, then we can define it, otherwise don't. Okay, so that seemed to have been the problem. Okay. So let's go through the other problems and see what happens, namely this one, 211341, right? And then we have n is 4, k is 2. Do we get output of 2? Yes or no? Yes or no? Yes, we do. And then what about this, where we have 1, 2, 1, and the output, or the node number is 2, k is 1, and we should end up getting an answer of 1. Bueno. And then what if we have n2, k2, which would then return nothing, or -1, because like starting from 2 doesn't go anywhere. We have no idea like where to go from 2, so okay, that's -1. So it looks like it passes these test cases. I'm gonna go ahead and submit it and see if it completes, or if we're missing something, if there's like a small error, syntax or otherwise. We could try to address it. And I wonder, it seems like the runtime's a little long, no? Oh, I guess not. 90 milliseconds isn't terrible. Okay, I don't know. I mean, it took longer to run last time, but okay, all right. So this is pretty much the way that I go about it. Obviously, I went a little bit of extra right here with this package item. Really quickly to show you, like, say if this didn't exist, like, it's literally almost a no-brainer. Like, you would basically use list of list integer, and it basically would literally be this, like, very small change. This, and then the what do you call it, the it would be this, and then what else would we do? We would, there'd be several, there's actually a couple changes. Let me see, I think I did one not too long ago that was using lists. Let me see. Yeah, here we go. This is the one I did where it's using lists. It's literally the same exact logic. I just wasn't using a custom class. And basically the idea is that you're just going to have a linked list for the graph's value. And then for the actual priority queue, like I mentioned, I decided to just use like an integer array. I basically, like, the only annoying thing is that you have to cast here. You don't have like the niceties of using like objects. You basically need to cast here, did R1 minus bar1. And one thing to keep in mind when you do the Compareto method, what I'm defining right here is a minimum heap, meaning that what I preference at the top of the heap is the smallest unit. If by some reason I am preferencing the larger unit, what that would be is basically bar1 minus R1. And the reason why this would be is because what would return is that bar1 is bigger than R1, it would return a non-negative integer. So if at any point in time you wanted to, like let's just say for example, if you want to have a better understanding of this, and it's good to have a understanding of this, let's just say if R1 is greater than bar1, return 1, else if R2 is less, or wait, R1 is less than bar1, return -1, right? Otherwise just return 0 because they're like the same number, right? And this should have the same exact output and the same exact like results basically. The hell is the issue? What's the problem? Oh, I was about to say, what the heck? So this is basically the same exact output, the same exact thing. The only reason I mention this is because there might be cases where like you want to like make it a little bit more customizable. Like say if you're not using integers, what if these two things were arrays? What if these two things were lists? What if these two things can't be quantified as an integer? What do you do when you can't minus? Well, the idea is that if you want it to be a minimum heap, which is what I want, if R1's greater than bar1, that ain't what I want. Return a positive larger than 0 integer. And I don't even know if you could, does it work if you do 5? Or is it, does it gotta be 1? I don't even remember. Oh, it's literally, if it's a positive integer, it literally is just like positive, negative. It literally doesn't matter, right? So for this case, return positive 1 or a positive integer bigger than 0, that, we don't want this. This is the case that we don't want. And then when we get to the case that we do want, return a negative integer that's, smaller than 0. And then when we get to a case where it's like pretty much middle of the road, they're equal, whatever, just return 0. The only reason I mention this is because it can get a little confusing if you don't know about like what to do with the Compareto method. Personally, I think that if you have the time to write a little bit of class like I did, it's pretty good. But if you're in a rush, you're used to doing what I'm doing, which is literally what I'm used to doing. Maybe you want to go with the tried and true and just tell your interviewer, hey, I'm going to use a custom comparator with Lambda as opposed to implementing my own class. To each his own. Pretty much the important piece of this is two things when you come into contact with Dijkstra's type of problems. One is basically putting it in a format you're familiar with. So for example, if I wanted to, I could have done this using the 2D array, the matrix. But if you do that, what ends up happening is that you go through, you basically get to the point where you now need to iterate over the different pieces. Like you're doing a for loop anyway. I like this representation. I like doing it this way because I feel like it's cleaner, it's a little bit more modular, and it's less annoying in my opinion. And I like the way it is, so that's the way I chose to do it. With that being said, that's pretty much it. I think in terms of shortest path finding algorithms, Dijkstra is pretty much the tried and true. If you can do this in an interview, great. It's a little bit time consuming, but once you do it enough and you understand the point of just organizing the data and then iterating over the data, and then literally all you're doing, the most of the logic is being taken care of by your priority queue or your heap. That's doing all the heavy lifting. It's just these little pieces of things to remember that, you don't want to, traverse the same node twice. You don't want to take the max value from the same node twice. Like whatever the first node value is, that's what the value is. Different small things like that. But for the most part, that's pretty much it.